Okay, in section 6.4, we're going to look back at a topic that we haven't done for a little bit. We're going to solve these polynomials here by factoring, but we're also going to do it by graphing. Okay, and I'm going to show you how to solve by factoring and graphing based off of what we did in section 6.3. Okay, so on the first problem, we've got w squared times w squared minus 1 equals 0. Now this was actually, the first factoring's already been done for you. They took out a greatest common factor. This would have actually been w to the fourth minus w squared equals 0. And what they did was they already took out a w squared, which left you with w squared times w squared minus 1. Okay? So now what we're going to do is we're going to go ahead and complete any additional factoring. Again, we've already taken out a w squared, but then here, w squared minus 1, that's a difference of squares. Okay, so that factors into w minus 1 and w plus 1, and that's equal to 0. Okay, again, this was a difference of squares, which I call DOS, difference of squares. And now that this is completely factored, we know this, or this has to be equal to 0. So you get w squared equals 0, or w is equal to 0. So there's your one value. Over here, we get w minus 1 equals 0, or w equals positive 1. And over here, we get w plus 1 could equal 0, or w equals negative 1. Okay? So there's your three values, or three solutions to this this polynomial. And again, we could do that by graphing as well. Remember, these are your zeros, these are your x-intercepts, because what we could do is we could actually replace in this equation this with y, or this with y. Okay? And so if we plug that in, if we said what y equals x squared times x squared minus 1, and we hit graph, and let me rezoom this. Actually, that's not a bad zoom, but let me rezoom. Zoom 6. Okay, you will see the graph here. A little hard to see. Let's zoom box this a little bit. Hit enter. We'll expand this out and down. Zoom in here, and look, there's negative 1, there's 0, and there's positive 1. If you wanted to verify that for sure, you would hit second table, and you would see at negative 1 you have a 0, at 0 you have a 0, and at 1 you have a 0. Those are your three solutions to this problem. Okay? So let's try number 2. Number 2, here's a factoring question. Now we haven't done this type of factoring question before. We have an x to the fourth. Well, this would actually factor into two binomials. Okay, and since this is an x to a fourth, but the middle is x squared, instead of the first term being x and x, this would be x squared and x squared, because x squared times x squared is x to the fourth, but when we do our outers and our inner terms, we're going to get an x squared for our middle. So now we need factors of positive 16 that get you negative 10, which appears to be negative 8 and negative 2. Negative 8 times negative 2 is positive 16. But when you do your outers, you get negative 2x squared and negative 8x squared, which gets you negative 10x squared. Okay, now it doesn't look like either of these are a difference of squares, because this is not a perfect square, the 8's not a perfect square, and the 2's not a perfect square. So now we're ready to set this or this equal to 0. So x squared minus 8 could equal 0, which means x squared would have to equal 8, which means x would have to equal, take the square root, you get positive or negative square root of 8, which is x equals plus or minus 2 square roots of 2. Okay. Then on this factor, we've got x squared minus 2 equals 0. So that means x squared would equal 2, which means x would equal plus or minus the square root of 2. And you can't do anything else there. So here are your solutions to this particular equation. Okay. And again, we could do this through graphing, but this one, when we go ahead and plug this equation in here, you will see we've got x to the fourth minus 10x squared plus 16. If we hit graph, and again, let me resume this. Actually, that's not a really bad zoom there. It's actually quite a nice zoom. But let me rezoom anyhow. Zoom 6. So here's our graph on this one. Okay. And you'll notice it looks like there's 1, 2, 3, 4 values of x there. But if I really bring this up close, you can see that this one here and this one here do not appear to be whole numbers. This one and this one don't appear to be whole numbers. So let me try to find the zeros through the calculation. So we're going to hit second and the trace button. And again, the x-intercepts are called 0, so I hit enter. And now let me find this furthest to the left one. So I need to hit my left-hand arrow. You can see the cursor moving over to the left. And I need to keep moving it till I'm on the left-hand side of that x-intercept, which I am now. So I hit enter. Then I need to move to the right-hand side of this point. So hit the right-hand arrow. I'm now on the right-hand side. Hit enter. And then if I make a guess as the same point I just selected, hit enter one last time, and you see the x-intercept is actually negative 2.82. So this is negative 2.82. Now you say, well, that doesn't make sense because I was supposed to get square roots, but see how this is a decimal? Well, this is going to be a decimal. What is, if we get to the home screen, 2 times the square root of 2? Look at that. It's 2.82. That's the same value that we had, on our graph when we did it on the graph. So these here, if we went through and calculated out all these zeros, we would get the positive 2 square root of 2, the negative 2 square roots of 2, the positive square root of 2, and the negative square root of 2. Those are our zeros. Okay? So you can get the decimal values on the calculator or the exact answers on the factoring. Okay? So I'm going to do one more here. On this one here, we've got, again, factoring. Since it's to the 4th power, there is no common factor, so we're going to have x squared and x squared. Factors of 16 that get you 8 this time. Looks like that's negative 4 and negative 4. Okay. And then both of these are difference of squares, so both of these factor into x minus 2, x plus 2. This is x minus 2, x plus 2. Okay. So our values of x are x could equal positive 2, or x could equal negative 2. Those are our x-intercepts. See, both of these would have a multiplicity of 2, which means they're even multiplicities, which means their graph must bounce. So if we look at the graph here on this one, here's the equation. Hit graph. This graph must bounce through those points. And see, here's negative 2 and positive 2, and see how the graph bounces off of each one? As opposed to, on this particular graph over here, this was the graph on the very first one where we had 0, 1, and negative 1. See how the 0 occurred twice. This was y squared. There was 2 of those. So at 0 it bounced. But at negative 1 here and at positive 1, they only occurred once, so it actually cuts through both of those graphs. Okay? So that's what we're doing on these. So you can solve it by graphing, you can solve it by factoring. Here you would have a greatest common factor of 7x, which would leave you with an x squared minus 9 equals 0. This would be a difference of squares, so 7x equals x minus 3. X plus 3. So your values would be x equals 0 from here. This would be x equals 3. And this would be x equals negative 3. And that's what you're going to be doing on these. You're going to factor, or you're going to do it by graphing. Okay?